Good morning. I'm happy to see many new faces in the assembly, in addition to very familiar ones. Today we have PolyWorks users from many manufacturing industries, including automotive, aerospace, consumer products, energy, and many others. We also have new and long-time PolyWorks partners. Welcome, all of you, to the 2018 edition of PolyWorks Conference USA. What brings us all together? Our shared passion for solving product engineering and manufacturing challenges using 3D measurement technologies, with PolyWorks at the core of the solution. At InnovMetric, it is in our DNA to innovate and leverage technologies that can help you maximize the return on your 3D metrology investments. Today, our societies and workplaces are being transformed by modern communication and information technologies, with the arrival of groundbreaking technologies such as the Internet of Things, cloud computing, big data analytics, and artificial intelligence. Manufacturing companies are challenged to embrace the fourth industrial revolution. But what does it all mean to you? What are the impacts of those technologies on your job? How can technology enrich the human experience and lead to personal accomplishment? We deeply care about your success. And as I regularly tell my employees, it is the only true metric when measuring the success of our organization. This is another important aspect of our DNA, and the PolyWorks conferences that we organize worldwide every year are the foundation of our strategy to ensure the success, the long-term success of all PolyWorks users, who we consider our colleagues. This year's edition is quite special. Over the next 2 days, the core program is focused on our vision of intelligent metrology solutions that will provide you and your company with the ability to create flexible metrology processes that play a key role in solving existing and future manufacturing problems. We will start with the 2018 release of the PolyWorks Universal Cubed platform, which materializes our vision for delivering fully universal inspection projects. It empowers users to create robust measurement sequences embedded in inspection projects that can be played using any portable or CMM measurement device. Then, this afternoon, we will show you how we aim to digitally interconnect hardware, software, and your product engineering teams from a single digital platform. We strongly believe that the next big gains in 3D metrology will come from providing all your team members real-time access to all 3D measurement data and inspection results. And be here tomorrow. We would like to share with you our 2020 vision of smart 3D metrology powered by PolyWorks, where flexible measurement processes meet digital collaborative processes, with an eye towards the integration of those groundbreaking technologies that are shaping the world around us. We hope that you will walk away enlightened, empowered, and embracing our vision of the future. You have our commitment that in the years to come, we will not only keep on delivering great products, but will also continue offering a unique human experience. I wish to all of you a great conference. Thank you.
Do you guys remember during the PolyWorks 2016 conference, our president, Marc Soucy, presented the Universal Cubed vision? Do you guys remember that? If not, maybe you remember the small gift we gave you that year, PolyWorks to the Cube t-shirt. This is also the year we had a nice sports bar activity during the evening. Well, During this 2018 development cycle, we have continued working to achieve this vision. We worked on the 3 dimensions of the universality with 3 goals in mind. First, providing you an easy-to-use workflow, thank you, to create your inspection projects, always the same way. Second, we are working to support as many devices as possible to offer you a universal digitizing hub. And finally, third goal is to provide you the possibility to create universal inspection projects so you can use these projects on all your devices. So you will see in this presentation this morning enhancements made to PolyWorks software to bring your universal metrology software to a higher level. We'll start off with my colleague Richard, who will present enhancements made to our interface to offer you a better user experience. Then I'll present the final development milestone in delivering truly universal projects. I will also present enhancements made to our universal workflow. And at the end, my colleague Martin will be on stage to present the additions we made to our universal digitizing hub. So let's get started. Please welcome my colleague, Richard. Richard?
Hello, everyone. As Éric mentioned, I'm here today to present how the user experience has been improved in 2018. User experience is important to us. We're proud to offer a really powerful software, and we keep developing new tools to meet your needs. But those tools, they have to be easy to find and easy to use. This year, we targeted 3 main aspects to improve the user experience. First, we've worked on the user interface, the toolbars, the menus, the objects, the colors. This is how you interact with the software to get work done. Then, we've improved the ease of use of the software. We know we have the tools, we just need to make sure you can find them and use them properly. Finally, to top this off, we've improved the performance of our software to save you precious time. Our end goal, whether you are a new user or an expert user, is to improve your productivity. Let's start with a quick preview of some of the changes we've done this year in terms of user experience. This is the PolyWorks 2017 interface that you're already accustomed to. But now, let's take a look at the brand new and enhanced PolyWorks 2018. The first thing you'll probably notice is a completely revamped color scheme. We've also simplified the icons for clarity and to give PolyWorks a more modern look. The simple thought of new icons might intimidate some of you, but look at them. You can probably recognize all of them. Interactions within the 3D scenes have also been enhanced by offering you tools easily accessible when you need it. You'll be also happy to see that the annotations are now locked in 3D, meaning that you won't lose them when moving the model around. This was just a quick preview. Let's now explore in more detail how the user experience has been improved. When you'll first install PolyWorks 2018, the first thing you will probably notice are the new icons for our main products. Here's the new icon for PolyWorks, PolyWorks Inspector, PolyWorks Modeler, and finally, PolyWorks Reviewer, which was formerly known as PolyWorks Viewer. Not only did we revamp the icons of our main products, we went all in and reviewed all the icons of the software. The main objective behind this was to improve the icon recognition. We started by removing the gradient, the shadows, the 3D effect, and then we removed as much detail as possible to keep the icon simple. We wanted to improve the icon recognition, but at the same time, we wanted to ensure a smooth transition to the new version. So we kept the original concept behind each icon. Finally, we wanted to pave the way for future products. These more modern icons will fit better in various other environments. For references and data object, we decided to use two distinct color palettes. For reference objects, we will use a gray palette, while we will keep a colored palette for data objects. This will allow you to know at a glance whether you're looking at CAD or data. You can also see that all the curves on the CAD models, whatever their types, now have the same color by default. Similarly, measurement objects such as features and comparison points, they now have the same default color by default. You can still change the color of any of those objects. We simply change the default color. In the past, we sometimes used bright red, green, and yellow for other purposes than to identify pass and fail status. For example, with the flush and gap gauge, the flush was always drawn in red and the gap in green, independently from their pass and fail status. And this could cause some confusion. So now, we're only using those colors to identify pass, fail, and warning statuses. PolyWorks is a large, well-organized toolbox. But there are lots of tools and options, and we know that this can be overwhelming, especially for new users. So we're working hard on making these tools easy to use to speed up your learning curve and increase your productivity. To create snapshots or control views, you often need to move the annotations in the 3D scene. And you want to also change the display options. To simplify this process, especially for new users, we wanted you to be able to find those tools and options on your own. We also wanted those tools to be only visible when you need it. To do so, we added a mini toolbar that pops above each annotation to allow you to do what you need with those annotations. Also, if you spend time manually positioning all those annotations, you probably don't want them to move from their new position. Therefore, we added a new mechanism that locks the position of those annotations in 3D so that they will move with the model. Let's take a look at a video that demonstrates those new functionality. In PolyWorks 2018, we're introducing new ways to interact with annotations. You can now simply put your mouse cursor above an annotation to access this mini toolbar. The main tool allows you to drag the position of the annotations. You will also notice that if you put your mouse cursor above an object, this will show the annotation if it was hidden. As I mentioned, once we move those annotations, they're now locked in 3D, so you can move the model around and you won't lose all those positions. All these actions no, sorry. If you want to go back to the automatic positioning, you can unlock the annotation position. You can also easily edit the annotation content from this mini toolbar. Finally, you can easily hide an annotation and restore it. All these actions were only affecting a single annotation at a time. But now when you move annotations, you also have access to a global toolbar at the bottom of the 3D scene. This allows you to change the positioning mode or the display options of all those annotations, or lock, unlock, hide, and restore all the annotations at once. Managing annotation is now easier than ever by having all these tools and options directly available in the 3D scene. Most of you know that PolyWorks has two main products: PolyWorks Inspector and PolyWorks Modeler. Some of you may only use one of these products, but for certain data processing workflow, it needs both PolyWorks Inspector and PolyWorks Modeler. They both have great tools that are complementary to each other. Inspector is where you will scan, probe, and use different measurement tools such as features and color maps. On the other hand, Modeler specializes in the editing of the polygonal models and the reverse engineering of 3D models. When you need to use both, you often need to transfer objects from one product to the other. To simplify this process, we now create a link between a modeler and an inspector project so that you can easily transfer objects with one click without the need for browsing. Let's take a look at a typical reverse engineering workflow to show you how you can use this tool. A typical process starts in PolyWorks Inspector. This is where you will scan, probe, and maybe extract some features from the mesh. At one point, you're ready to transfer the scan data to PolyWorks Modeler. In PolyWorks 2018, this is easily done with a single click. This will create a new modeler project, import the object, and link the two projects together. Now in Modeler, you can continue the reverse engineering process. You can remove some features, fill the holes, create some curves, get NURBS patches, and eventually you'll get a NURBS model. In this example, we have the global shape of the object, but we're missing the two holes at the bottom. To get those, we can go back to our inspector project, select the two probe circles, and just transfer them to Modeler. Thanks to that link, we know in which project to send those circles. So now in Modeler, you can easily punch those two holes, and you'll have a complete 3D model. This process can go both ways. It can also go from Modeler, so you can take that NURBS model, bring it back to the original inspector project to do, for example, a color map between the final 3D model and the raw, unedited scan data. Performance. One of our ongoing objectives is to allow you to work as efficiently as possible. To do so, one approach is to identify key long operations and to shorten them by optimizing their algorithms. This year, our main focus was on improving the import of CAD models. When we import CAD models, we do a lot of processing. For the IGES and STEP format, This process was already multi-threaded, but for other CAD formats, a lot of the processing was still done using a single CPU. In PolyWorks 2018, we're now reusing the same technology as IGES and STEP format to fully benefit from all the available CPU. This will cut down on the import time by a huge factor. Basically, the bigger the model, the greater the gain. To summarize, icons have been simplified to make them easier to identify. Colors have been adjusted for clarity and to remove ambiguity. Annotations are now easily managed directly from the 3D scene. Transferring objects can now be done with a single click between products, and the import of CAD model is faster than before. All of these improvements will improve your day-to-day productivity when using PolyWorks. This concludes my part. Thank you very much. I will now invite Éric back on stage to continue this presentation.
Good job. Thanks, Richard. So we've gone through the enhancements made to the user experience. Let's move now to the second part of today's presentation, universal projects. What is a universal project? It is a project that can be used on any of your devices. This ambitious development project started 6 years ago. In 2012, we developed the multi-piece architecture. Projects could now contain multiple pieces in a single project. In the next 4 years, we developed the support of the CNC CMMs, a fundamental building block for the universality. In 2016, we developed our conversion tools, so you can easily take an existing project and reuse it on a different device using those conversion tools. The same year we developed the offline simulation mode. Offline simulation mode is a key technology to create inspection projects. Now, this year, we are introducing the new piece template technology, the final milestone in delivering you truly universal inspection projects. So with PolyWorks 2018 and the new piece template technology, you will be able to use your project on a variety of devices. When measuring a new piece, the operator will be able to choose which piece template to use according to the available device. Switching from a CNC CMM to a portable arm has never been this easy. It's one click to choose the template. There are many advantages of using different devices when measuring pieces. You will see in this demonstration that with the new piece template technology, it's not only a great advantage when changing devices, but it also offers the possibility to use different measurement plans, different measurement methods, different CAD models. So simply said, we are offering you shop floor ready universal projects. So before discussing about this new piece template, let's have a quick look at what we have today, what you guys have with PolyWorks 2018 when you want to measure multiple pieces. Today, with PolyWorks 2017, you have to create a first piece that contains the necessary information. The CAD model with the nominal features, the device to be used. The measurement methods must be defined inside the objects. the measurement sequence must be created. So this piece number 1 is the starting point for the multi-piece inspection workflow. When you measure a new piece, the previous piece is used as template. But what happens today if the targeted device is not available? If the arm is not available here, you have to create a new piece and perform some project modifications. The active device must be changed. The measurement methods must be adapted. The measurement sequence must be adapted as well. So my colleague Jean-Sébastien will go through these conversion steps later today in the workshop. Jean-Sébastien will show you how to convert your project. But to minimize risk of operator errors on the shop floor, don't you think that these conversions should be planned ahead of time? Well, this is exactly what the piece template is all about. The piece template is a new and easy way to define within a single inspection project multiple piece templates. So each piece template will contain the necessary information for a particular workflow for a particular device. And as you saw in the video, the operator on the shop floor can choose the piece template of his choice for his part measurements. A big benefit is that all these pieces are saved in a single inspection project, so you can use the multi-piece analysis tools such as SPC or Surface Data SPC. So this project you see on screen is truly universal. Our goal has been reached. This project can be used on multiple devices. So let's have a look now at different use cases that will benefit from this new piece template technology. We've identified 5 interesting cases to demonstrate the flexibility of the new tool, this new tool. That's use case number 1. Your metrology lab is equipped with a CNC CMM and a portable arm. The CNC CMM is quite in demand, so you want the flexibility to use the arm when needed. To do that with the piece template, it's easy. You create a first piece template for the CNC CMM, copy the piece template, convert the sequence with our conversion tools, and the universal project is ready. Case number 2. Your metrology lab is equipped with CNC CMM, 2 CNC CMM. One is a portable, horizontal bridge, horizontal arm and bridge, so 2 type. Again, you can create 2 piece templates. What you have to do in this case, adapt the second sequence by matching the corresponding tools. The main difference between those 2 CMMs is the tools. The tool list is different. In this example, you might not use CNC CMMs, but you have access to 2 different brands of laser trackers. Once again, you can create 2 piece templates. What you have to do in this case, simply adapt the reflector names and potentially probing modes inside the measurement objects. And you're ready to deliver a universal project on the shop floor. So we've just seen 3 examples of using the new piece template technology that allow you to prepare your project for different devices. But the universality of projects goes beyond interchanging devices, and I'll demonstrate that with 2 other examples. In this example, let's say you are producing car doors, but you have 2 different models to produce. We can see on the screen CAD model version A and CAD model version B with additional holes on it. So once again, you can create 2 piece templates, one for each CAD model, and the operators on the shop floor are ready to use one or the other, depending on the part they have to inspect. Here's a last example. You work for pre-production, you are measuring critical characteristics on those pre-production parts. But every 5 pieces or every 10 pieces, you need to perform a full inspection on all characteristics. Once again, the piece template is the solution. You can deliver a project on the shop floor that is ready for both scenarios. So with PolyWorks 2018 and the new piece template technology, you will benefit of a very flexible work organization. All the operators on the shop floor will be ready to use any of the available devices. This will maximize the use of your measuring devices, and this will also reduce the risk of operators' errors, as no conversion or no editing is required on the shop floor. So, as you guys know, using PolyWorks not only guarantees universal projects, it also gives you a universal workflow. You can create the core of your inspection projects always the same way, regardless of which device will be used in the end. One important aspect of this universal workflow is how you align your parts. You guys know that the alignment is critical. So this year, we've enhanced our alignment toolbox. I will first present enhancements made to our reference target alignment to better support balanced alignment. Then I'll show you an addition we made to our datum target toolbox. Balanced alignments. One interesting case, it's probably the most important case for the automotive industry, measuring symmetrical parts. When measuring symmetrical parts like this car hood inner, often the datum specifications requires to balance the deviations on both sides. You want the deviations to be balanced on both sides of the part. So to do this kind of alignment today, you can create targets to lock the Z directions, 3 or 4 targets. We typically use holes to lock the X. And for the Y direction, you can define surface points or trimmed edge points on both sides. Now to balance this alignment in the Y direction, you can do that today. Some of you have tried it, I'm sure. You can create midpoints and use those midpoints in the reference target alignment. If you have tried that today with PolyWorks 2017, you found out that the alignment is not balanced. You need to run a macro script to get a balanced alignment with PolyWorks 2017. So, to be able to perform these balanced alignment without using any macro scripting, we've enhanced the reference target alignment. So you can now bind constructed features like midpoints to reference targets. And during the alignment, our new algorithm will iterate until the deviations on both sides are equal and well balanced. So, this development offers you a lot of flexibility. You can create surface points on both sides, trimmed edge points, hemmed edge points. You could even use calipers. You could use calipers to balance your alignment. As long as you can construct the midpoints, you are good to go. This technology is also very useful when aligning blades. Is any of you guys are aligning blades? I'm just curious. Any in the blade industries? Some? So this is critical for blade inspection. If you want to balance, for example, leading edge of blade or trailing edge of blades, you need to have this new algorithms. In this example, we have balanced the trailing edge of the blade. This is also useful for aligning blade assemblies, as you can balance the gap between blades. Okay, there is one last item I'd like to present you today before I hand the mic to my colleague Martin. It is about datum target. As you know, datum targets are generally used to simulate the alignment of a part in a fixture, in a physical fixture. In some cases, if you are measuring rigid parts like castings, you could even eliminate the need of the physical fixture if you have access to the right tools on the software side. With PolyWorks today, we already have a nice solution to create datum target points, datum target lines, but we are missing something important. We're missing the datum target area. So to precisely simulate the alignment of a part in a fixture, you need to be able to define the locating pad's position, shape, and size. And when you look at the inspection drawings, we typically see rectangular and circular datum target areas. So in upcoming intermediate releases of PolyWorks 2018, you'll be able to create datum target area, a circular shape or rectangular shape. Combined with datum features, you will be able to simulate fixture alignments. So if we summarize the key benefits of these new alignment tools, so you'll have the possibility now to balance alignment on symmetrical parts or blades using a well-integrated solution. And with the new datum target area that will be delivered in IR3, IR4, that's the plan, you'll be able to simulate, to truly simulate the alignment of part in a fixture by defining the locating pad's position, shape, and size. So that concludes these two parts of today's presentation about universal projects and universal workflow. I will now invite my colleague Martin on stage to present the additions we made to our Universal Digitizing Hub. Martin?
Thank you, Éric. Good morning, everyone. This last part of our product presentation will address hardware support. As PolyWorks is a universal digitizing hub, we're always aiming to extend and improve our support for digitizing devices. And this 2018 release makes no exception. In this next and final part, we'll see custom measurements, typically taken with manual gauges, improvements to the multi-CMM workflow, and new additions related to CNC CMM metrology, hardware, and functionalities. Let's begin with custom measurements. Although PolyWorks supports practically all portable scanning and probing systems, there are applications where some specialized instruments are necessary to measure certain characteristics. In this new release, you can input results from any device or operator observations. For example, some of you may take numerical measurements using digital micrometers, calipers, or flash and gap gauges, to mention a few. Or you may want to report qualitative observations, for example, to validate the absence of defects, such as sink marks on plastic parts. or to validate the presence of certain features like pilot holes for sheet metal assembly. Here's a PolyWorks inspector project with custom measurements. A measurement sequence has been prepared for the operator who launches plane inspection. When it's time for a custom measurement, a guiding text and image are shown. In this example, some measurements have to be taken using a digital caliper. The operator measures and types in the results in the dialog box. Then he is asked to do a visual spot weld check. He goes through the spot welds following the 3D scene for guidance to the appropriate locations, then selects pass, fail, or warning for each one. The rest of the measurements are performed as usual. When inspection is complete, results can be reviewed in PolyWorks Reviewer. Just like other measurement objects, custom measurements can be reviewed in 3D using 3D scene annotations. Custom measurements are also available in control views. In this example, there is a control view dedicated to spot weld checks. Thanks to custom measurements, you now have 100% complete inspection projects. You no longer need a separate spreadsheet as every characteristic is included in your project and report. The operator has full guidance for measurement thanks to locations displayed in the 3D scene and to guiding images and text. Finally, you can review the results in 3D using 3D scene annotations and share with your team using PolyWorks Reviewer. PolyWorks 2018 also introduces enhancements to the multi-CMM workflow. In PolyWorks 2017, our design for the support of multi-CMM setups was based on a workflow where you prepare a sequence in advance for each CMM. In those sequences, synchronization steps allow exchanging measurement data between the computers. But in many cases, there's no advantage in preparing sequences in advance. This is especially true with manual CMMs, where operations are typically performed directly on the CMM without a sequence. But even with a CNC CMM, sometimes the inspection of a part is not going to be repeated, like when a part is being prototyped and is not yet in production. To handle such cases, we now allow synchronizing on demand outside a sequence, while still offering the possibility to synchronize within sequences. In a common workflow, one operator drives the CMMs moving from one to another. He can measure on one machine, and thanks to the synchronize function, he can share measurement results with the other machines. This allows him to move from one to the other and to continue measuring. The synchronize function also applies with multiple operators. After having measured alignment features, the synchronize function allows to compute the alignment, and then the measurements can be performed. In short, PolyWorks now allows you to efficiently measure with a multi-CMM setup, whether you use a sequence or not. Now let's move on to CNC CMM metrology more specifically. Before we look at new functionalities, let me summarize the new hardware that's now supported. First, we keep putting a lot of effort into laser scanning. Why? Because with PolyWorks power and expertise in processing laser scan data, you can turn an old CMM into a high-precision scanning device and give it a new life. To allow more and more customers to benefit from this, we now support the Zephyr 2 scanner from Crayon Technologies, and the rest of their CMM scanners will be supported in upcoming intermediate releases. And this is in addition to the complete range of Nikon CMM scanners that were already supported. As for CMM controllers, we now connect directly to Mitsutoyo CMMC controllers. This is in addition to already supported UC controllers. Even though CMMC controllers are older, they're still quite common. We also connect directly to SB Electronics CNC 06 controllers, which are typically used on Stiefel-Myers CMMs. And we offer the new Zeiss CMM plugin, CMMOS plugin, to connect to Zeiss CMMs with no need for a Zeiss I++ server license. This is in addition to already supported Hexagon, Nikon, Pantec, and Wenzel controllers. When it comes to probe heads, PolyWorks now supports inferred calibration. In projects where a large number of tool orientations are used, inferred calibration saves time by not having to calibrate all tool orientations. When a head supports inferred calibration, a head calibration function can be invoked. And once the head is calibrated, calibrating a single tool orientation computes automatically the calibration for all orientations of this tool. We directly support the PHS-1 from Renisha, which is a popular head in the automotive industry. And through the I++ CMM plugin, any head supporting inferred calibration can be used. As for other CMM hardware, we now support quill adapters, often called cubes. They are mainly used on horizontal machines to allow installing the head such that the probe or scanner is pointing down. And we support rotary tables on Nikon controllers. This sums up the additional hardware that's now supported. Now let's move on to new functionalities for CNC CMM metrology. It's sometimes a challenge to create a robust measurement sequence on a CNC CMM. For instance, when a part is being prototyped, features on the prototype part are not always located as specified by the CAD model. PolyWorks offers 3 new tools to help you build robust sequences to measure deviated parts. In this project, the CAD model is displayed in gray and the actual part in green. You'll notice that the actual shape doesn't exactly match the CAD model. This is typical on sheet metal parts. This hole has a very thin surface on which a local plane has to be probed. Since the hole is deviated, probing would fail if the deviation was not taken into account. The new locate hole center functionality takes 3 points to estimate the location of the hole, and then from this estimate, the measurement location is adjusted to properly measure the hole, the local plane, and the hole itself. There are also small holes for which CNC probing could easily fail if they're deviated. With the new hole search functionality, if the hole is not at its nominal location, a spiral search will be triggered to find it automatically. And when the hole is found, its location can be determined more precisely using the locate hole center functionality that we've just seen. Then measurement is performed. You can also use a deviation of one hole to adjust the measurement location of other holes. The relative offset tool is an efficient way to measure multiple deviated features. In this example, the deviation of the first hole is used to adjust the measurement location of the second small hole. This tool is flexible as it supports relativity to any number of objects. With locate hole center, search hole, and relative offset, you have all the tools you need to build robust measurement sequences for CNC measurement of deformed parts. In PolyWorks 2018, we've also enhanced our collision analysis tools. An important addition is offline collision detection. When preparing a measurement sequence with collision detection activated, PolyWorks warns you if there's a risk of collision by way of icons in the measurement sequence and red lines in the 3D display of measurement paths. This is done in real time as the sequence is edited And yeah, that's it. And often sequences are also built by recording operations directly on the CMM. And to prevent collisions in this case, detection is also available while the operator is interacting with the CMM. This is something that traditional CMM software generally doesn't support. If an operation creates a risk of collision with the part, with the fixtures or CMM table, a warning message is displayed to the operator before the operation is performed on the machine. Supported operations are change tool orientation, go to position, as well as CNC probe and CNC scan. But that's not all. We not only detect collisions, we also help you avoid them thanks to the automatic generation of collision-free movements. Suppose your project contains two features for which the CMM cannot directly move from one to the other. On the collision icon, a fixer allows you to insert automatically computed go-to steps to avoid the collision. PolyWorks computes intermediate points to define the shortest path that does not collide with the CAD. Most of the time, one go-to is sufficient, but PolyWorks also handles more complex cases and can also fix multiple collisions at once. This will be covered in more details by my colleague Roberto in a workshop tomorrow. Here are the key benefits of collision detection and avoidance tools. You get immediate feedback as a measurement sequence is edited or while performing operations directly on the CMM thanks to real-time analysis. Using automatic go-to position makes it quick and easy to create collision-free measurement paths. And finally, you can rely on the collision analysis tools no matter whether you're working online or offline to minimize the risk of collision. With those new tools, PolyWorks is moving one step further towards the automatic generation of smart CMM measurement paths. So this concludes our presentation on what the new PolyWorks 2018 release has to offer.
Briefly, what are the key benefits of this new PolyWorks 2018 version? Give me a sec. Okay, we're back. So the first benefit of this new release is about piece template, with the possibility to create not only one, but multiple piece templates inside a single inspection project. You guys are ready to deploy truly universal inspection projects on the shop floor that are playable anywhere on any of your measuring devices. The second benefit is related to CNC CMMs. With the addition that Martin presented, the addition we made to be able to search holes, to locate hole center, the relative objects, and the great enhancements made to our duplex CMM solution, we are now ready for your sheet metal inspection on CNC CMMs. We have all the major functionalities. And finally, Richard presented you enhancements we made to our interfaces to offer you a better user experience. Well, better user experience means enhanced productivity for you guys. So thank you very much, and it's time to play with the new release. When is this new release available to our users? Right now, so it's ready for you guys. Thank you.